Okay, we're going to look at different transformations of our basic functions. These are, again, the whole reason we do it, like we obviously know you could just put these functions in your graphing calculator. The point is to know them without a calculator. So again, should know, know without a calculator. Okay, so if A is negated, then that is a reflect over the x-axis, because it's kind of negating the whole thing that y equals. If y equals that thing and then we put a negative out in front of it, we've just negated what y equals. And if you think back to your geometry days, when you negated the y, that was a reflection over the x-axis. The A value tells you if there's a vertical stretch, which is if the absolute value of A is greater than 1, or a vertical shrink if 0 is less than the absolute value of A, which is less than 1. Basically, if you have an A between 0 and 1. And again, the reason they're saying absolute value is because we're not taking the sign. We already know if A is negative, it's a reflect over the x-axis. If B is negative, it's a reflect over the y-axis. The value of B tells us there's a horizontal stretch, and that would be if 0 is less than the absolute value of B, which is less than 1, or horizontal shrink if the absolute value of B is greater than 1. C is our right or left shift. If it's plus C, it goes left C units, which kind of is, backwards of how people would think. Plus you would think going right, but it's actually going to be left C units. And that's because the initial formula is really a minus in the middle. So if you think about it, like if it's x minus the C, if the C is, if this is x plus 2, well, that really means x minus a negative 2. So the C would kind of be like a negative 2. But we just go, if this is plus, you're going left. Minus C is right C units. And D is up or down shift. Plus D is up D units. Minus D is down D units. Okay, so here's a perfect example of where I could give you something that you would not be able to use your calculator for. You can't plug this function in your calculator. I'm just going to identify this is at 1, 3, this is at 3, 3. This point here, like right about here, looks at 2, 2, and this looks at 5, 0. So if we graph the given transformations, this would be a reflect over x-axis because the f of x, the y, is negated. If they negate the x, then that's a reflect over y-axis. The -1 is a right one. So remember, that's kind of the one we think of as backwards. It means that that c is a 1. It's a positive 1. So because the formula is x minus c or x minus h or whatever, they use different variables. F of x minus 3, that's going to be a down 3. So you're taking the y, you're subtracting 3, so you're going down 3. Now, the half in the parenthesis with the x, that's going to be, and I'm just going to say a multiply, x coordinate by 1/2. And this one with the 2 out in front, this is going to be multiply y coordinate by 2. Oh, I'm sorry. This last one. Multiply the x coordinate by 1 over 1/2, which is 2. And actually, I should maybe put this up here. When we have the vertical stretch, we also sometimes just say that's a multiply y's by the absolute value of A. And for the horizontal, we'll often say multiply x's by absolute value of 1 over B. So that's what actually happens when we do that transformation. So that's where I'm getting this down here. We're going to multiply the x coordinate by the reciprocal of what's inside the parenthesis. For f, we're multiplying the y coordinate by what's outside. So if this is A, this is where we're supposed to reflect over the x-axis. So that means we negate the y value. So 1, 3 is now going to go to 1, -3. 3, 3 is going to go to 3, -3. 2, 2 is going to go to 2, -2. And 5, 0 is going to stay at 5, 0. Because if you negate 0, you're still at 0. So that is what it would look like if we reflected over the x-axis. For B, it's reflect over the y. So when you reflect over the y-axis, you negate your x value. So 1, 3 goes to -1, 3, 3, 3, -3, 3, -2, 2, and -5, 0. C, right 1. So 1, 3 is going to go to 2, 3. 3, 3 is going to go to 4, 3. 2, 2 is going to go to 3, 2. 5, 0 is going to go to 6, 0. So you're adding 1 to the x coordinate. For D, down 3. So we're basically subtracting 3 off of the y coordinates. So 1, 3 goes to 1, 0. 3, 3 goes to 3, 0. 2, 2 goes to 2, -1. You're subtracting 3 off of the y coordinate. And 5, 0, we're going to go to 5, -3. Again, subtracting 3 off of the y coordinate. Okay, E, multiply x coordinate by 2. So this would be a 2, 3. 3 times 2, that would be a 6, 3. 2, 2 then goes to, if I multiply the x coordinate by 2, it'll go to 4, 2. And then obviously that 5, 0, it's going to go out 6, 7, 8, 9, 10. We're going to be somewhere way out here. And finally, F, multiply the y coordinate by 2. So 1, 3 goes to 1, 6. 3, 3 goes to 3, 6. 2, 2 goes to 2, 4. Right? So the x coordinate's staying the same, but the y coordinate's getting multiplied by 2. And then 0 times 2 is still 0. So notice we said if we multiply, the y's by something greater than 1, it vertically stretches the graph. And going back to E, we said if we multiply the x's by something greater than 1, it's a horizontal shrink, or sometimes people think of it, it pushes down on the graph and compresses it. Okay, state the transformations needed to obtain the graph of f of x from the basic function. Graph each transformation until you get the f of x function. State the domain and range. Okay, so we don't have to necessarily graph all of these, but I'm going to show you a few. So I usually say, okay, basic function is y equals x cubed. This is a cubic function. So this is going to be step 1. I'm going to graph the basic function. Step 2, that -1, remember, is a right 1. Shifts the graph right 1. The 3, or step 3, that +2 is an up 2. So what I always want people to do when we do these transformation graphs is you first graph the basic function, 0, 0, 1, 1, 2, 8, right? 2 cubed is 8. -1, -1, -2, -8. There's your basic function. Then what I recommend is people take a different color and shift every point right 1. So every point on this graph is going to go right 1. Okay, then off of that graph, we're going to go, and sometimes I, show what color I'm using. So I go up 2, and there can be some overlap, and that's why sometimes we, use the different colors. And those are sometimes steps that I say you can do all in the same step. If you want to, like if you did the right 1 and the up 2 in one step, that's fine. Here, number 1, basic function is y equals cubic root of x. And then the negative out in front is a reflect over x axis. So let's say I do the basic function in red. Cubic root of 0 is 0. Cubic root of 1 is 1. Cubic root of 8 is 2. Cubic root of -1 is -1. -8 is -2. And then you would take a different color, do a reflect over the x-axis, which negates the y value. So 0, 0 stays in the same place. This comes over here. We go -8, 2, 1, -1, and 8, -2. Okay, so our final graph, domain, all reals, range, all reals. I'm just realizing I didn't do the domain and range of this first one, but those are basically all reals. So I'm talking about the domain and range of the final graph. Oops, okay. Okay, next one, basic function is y equals square root of x. So these are all coming off the basic functions we did in day 1. That negative under the radical is a reflect over y-axis. And then the -3 is a down 3. Now, biggest question I get here is, does it matter what order you go in? I always tell people, the reflect over the y-axis has to get done before anything else. That's one of the big ones that matter. And the up-down is always last. So I usually go kind of in order from left to right, except if there's a reflect over the y, we do it first. Up, down, we do last. So then that's kind of always the case. Okay, so this one, I might just not even graph. Here, basic function, y equals absolute value of x. Now, sometimes I think of like going, or following order of operations. So if I go inside the parenthesis, or not parenthesis, absolute value bars, I have a left 3, multiply y's by 2, or that's a vertical stretch of 2, but I let people say multiply the y's by 2, just so you remember that's literally what you're going to do. You're going to multiply the y's by 2, and then a down 1. Okay, so absolute value, this is the one that looks like a V. So it's going through, the corners here of the graph. Okay, then we're going to do a left 3. So then every point gets moved left 3. And then again, just goes diagonally through the corners. Then from there, you're going to multiply the y's by, I just realized, sorry, I went right 3 and not left. That was dumb. Okay. Sorry about that. Okay, so left 3. This would go 1, 2, 3, and then we would go diagonally through the corners. Okay, so now multiply the y's by 2. So 0 stays at 0. 1 goes up to 2. Gosh, this is so hard to see here. 2 is going to go up to, where it's at a y value of 2, it's going to go up to 4. And then, same thing over here. Where it's at 1, it's going to go up to 2. Where the y is at 2, it's going to go up to 4. And then, basically you're going to have this. But it vertically stretches. And then finally from there, you're going to go down 1. So every point is going to move down 1. Okay, so domain would be all reals. Range is hard bracket -1 to infinity. Okay, so for this one, basic function is y equals 1 over x. We are going to multiply y's by 2 and then up 4. Now, let's talk about how we know this is a multiply the y's by 2. If you think about it, the reciprocal function is 1 over x, right? Well, if you think about it with fractions, the way you multiply something by 2 over 1, is what happens is the 2 ends up in the numerator. So it's a 1 over x function, but it's been multiplied by 2. This one I'm not going to bother graphing because we do that more in a rational functions unit. And actually, I don't even think I'm going to graph this one. I'm just going to talk about basic function, y equals square root of x. Oh, this is a good one to look at. We need to rewrite this one because we have a negative underneath the radical. So I'm going to write this to -x plus 4. Then what you have to do is factor out the negative. The reason you have to do that is you will not get your right or left shift correct if you don't factor out the negative. So now if I'm underneath the square root, that negative tells me reflect over the y-axis, which always has to get done first. Then it's a right 4, which I would not have known if I didn't factor that negative out. I would have thought it's a left 4. And then finally, a multiply y's by 2. And technically, a lot of times, like the right and the multiply, those can be done interchangeably. But I just kind of feel like if you always like follow the order of operations, make sure your right, your reflect over the y is done first and your up down is done last, then you'll always get it right. Okay, so that's day 2, transformations.